Okay, Unit 1B, Day 1. In this unit, we're talking about parallel lines and angle relationships. So let's start off by looking at this first image. If two parallel lines are cut by a transversal, then we have all this information down here. So a transversal would be considered this line here, EF. Because it is cutting two parallel lines, and here we have AB is parallel to line CD. So these two things are parallel. Okay, we call in between these two lines, we call this area here the interior, because it is between parallel lines. And then on the outsides here, both of these areas, this area down here, that's the exterior. Okay, so let's look at the different relationships we have. So first we have vertical angles and linear pairs. Both of these things, they share a vertex. So these are angles that share a vertex, so they share like the point in between them. So let's look. Vertical angles are angles that are like opposite each other. So first, if I have up here, if I'm saying angle 1, and so angle 1 is opposite of angle 3 here. Angle 1 and angle 3 are considered vertical pairs, or vertical angles, and they have a shared vertex there. Their relationship is they are congruent. Congruent angles. So if I said the angle 1 is 100 degrees, then angle 3 would be 100 degrees. Next thing, sharing a vertex would be these linear pairs. So angle 1 and angle 2 would be called linear pairs. There's a pair of angles that are on the same line. They are supplementary, which means they add up to 180 degrees. Okay, so angle 1 and 2 would be supplementary. Angle 1 and 4 would also be supplementary. So if angle 1 was 100 degrees, then angle 4 would have to be the 80 degrees because they sum to 180. And similarly, if angle 1 is 100 degrees, 2 is 80 degrees. And now I can see that 2 and 4 would both be 80 because they are vertical angles. I can find a lot of relationships. We have linear pairs all over this, 2 and 3, 3 and 4, 6 and 5, 5 and 8, all through it. Okay, the next ones here, we have alternate interior angles. So alternate means opposite. Interior angles. Okay, so they're on the opposite sides of the transversal, opposite sides of this transversal, and they're on the interior. So first, if I said angle 3, that's on the interior. Now the opposite side of the interior would be angle 5. So angle 3 and angle 5 would be alternate interior. Then if I looked at 6, so angle 6 and angle 6 is on the inside. The other angle on the opposite side of the transversal on the inside would be angle 4. Those are alternate interior, and their relationship is congruent. Alternate exterior angles. So alternate meaning opposite, exterior meaning outside. So first, if I started with angle 1, okay, that's on the exterior. The other angle that's on the opposite side of my transversal and on the outside would be 7. So 1 and 7 are alternate exterior angles. For angle 2, that would be 2 and 8. That are alternate exterior. Their relationship is congruent. Okay, now the next piece is consecutive. So consecutive means same side of the transversal. So they're next to each other. Consecutive interior angles. So angles together on the inside. So for here, if I have 3 is on the inside, so same side of the transversal, 6. 3 and 6 would be consecutive interior angles. Angle 3 and angle 6, their relationship is supplementary. So they equal 180 degrees if I add them up together. Corresponding angles, so this would be like angles that, so one interior and one exterior on the same side of the transversal. So if I look at my picture above, okay, angle 2 is on the left side of my transversal, okay, and it's on the exterior. So I'm looking on the left side of the transversal and on the interior now. So here's my transversal, left side, interior would be 6. So angle 2 and angle 6 would be corresponding angles. 2 and 6. So we're looking at which one's kind of in the same place. So if I said angle 3, well, the corresponding angle for 3 would be down here at 7. 3 and 7. If I look at, ignore this, 3 is in the bottom left of this, these angles on top, so bottom left would be angle 7. The relationship there is congruent. Congruent angles. All right, the next section, let's just identify the relationships here. So on example 1, I have angle 1 and angle 8. So if I look at this here, angle 1's on the outside and the left side of my transversal. It's on the exterior. Angle 8 is on the exterior as well, but it's on the opposite side of my transversal. So that would be alternate exterior angles. All right, 4 and 5. 4 is here, 5 is here. They're on opposite sides of the transversal, so alternate. And they're on the interior of the parallel lines, so alternate interior angles. Two and 6. 2 is on the outside and on the right side. So the exterior and on the right side of my transversal. 6 is on the interior and also on the right side of my transversal. They're in corresponding spots, so we would call those corresponding angles. Okay, 6 and 1. 1 is on the exterior and on the left side. 6 is on the interior and on the right side. They don't have a relationship here, not a direct relationship. So we would just call this, if there is no name for it, no name for the relationship, we just put no name. 3 and 5. So 3 is on the left side of my transversal, 5 is also on the left side, and they're both interior angles. So that would be consecutive interior angles. They're kind of in a row right next to each other. So angle 3 and 5 are consecutive interior angles. Next page. All right, so it says here, given measurement of angle 1 is 115 degrees. So I'm going to write that right there, 115 degrees. Find the measure of each missing angle and give your reasoning. Use the picture above. Okay, so we could go through and find the rest of these angles. We just have to put a reasoning here how we were able to do that. So let's start here. Angle 1, I can go ahead and find angle 2 because angle 1 and 2 are linear pairs. They're right next to each other, share that vertex. So angle 2 would be 180 minus 115. So that should be 65 degrees. So angle 2 should be 65 degrees. How did I know that? Linear, because angle 2 is a linear pair with angle 1. Now angle 3, Angle 2 and 3 share that vertex. I could say angle 3 is linear pair with angle 1 as well. I could also say that 2 and 3 are vertical pairs, and that's how I can say that angle 3 is 65 degrees as well, because it is vertical to angle 2. Angle 4 is 115 degrees. I have a lot of reasons here. I can say 1 and 4 are vertical angles, 2 and 4 are linear pairs, or 3 and 4 are linear pairs. So let's see, linear pairs to angle 2, vertical, or vertical to angle 1, or linear pairs with angle 3. Now angle 5. Angle 5 is here. Okay, I have a few different ways I could do this. I have that 5 are congruent because they're alternate, opposite sides of the transversal, interior. So angle 5 is 115 degrees because alternate, interior with angle 4. I could say that they are corresponding to angle 1. I could say that it is consecutive interior with angle 3. That's why I was able to do that subtraction. Got a lot of options. Angle 6 then should be 65 degrees. Multiple options. Again, 5 and 6 could be linear pairs. Or I could say it's corresponding to angle 2, so corresponding with angle 2. Angle 7, 6 and 7 are vertical pairs, so 7 should be 65 degrees. Vertical pairs with angle 6. I could also say that it is angle 7 should be 65 degrees. Let's go alternate exterior with angle 2. All right, and the last one, angle 8, there, should be 115 degrees. Hopefully by now you're catching on. There's a lot of different reasonings we could use for some of these. So I'll just go linear pairs with angle 7. Okay, so if I had cut another transversal over here, I have a lot of options. So if I had 2 lines cut by 2 different transversals, I can compare this angle and I can ignore that bottom line. I can compare this angle with this one here and say those are alternate exterior. I could also ignore this line and compare this angle and say that those are alternate exterior as well. So on your homework, you have to do that. And notice how I was seeing how I compare these two. I just completely covered up this extra line here. This last section, let's throw some algebra in with it. So if L is parallel to M, so L is parallel to line M, find the value of each missing variable. State the angle relationship used to solve. So first we have angle 4 and angle 5. 4 is 5 is here. They're on the opposite sides of the transversal, so alternate, and they're on the inside of the parallel lines, so alternate interior angles. So alternate interior. Because I needed to state the relationship. You have to do that on your test as well. Angles, and those angles should be congruent, right? Alternate interior are congruent. If you ever forget, you have this whole side that you could go back and look at. Alternate interior, congruent. And let's go ahead and set them equal to each other now. So 11x minus 47 equals 6x minus 2. I'm going to go ahead and move my x's, so subtract 6x on both sides. 11 minus 6 is 5, so 5x minus 47 equals negative 2. Add 47 to both sides. 5x equals 45. Divide both sides by 5. So x equals 9. Next class we'll do more with that. Then we have angle 5 and angle 3. So angle 5 is here. Angle 3 is here. They're right in a row, so that would be consecutive. They're on the inside, interior. And they're on the same side of the transversal. Consecutive interior angles. They equal 180. So let's add these two pieces up together and set them equal to 180. 5x plus 3 plus 9x minus 33 equals 180. Combine our like terms. 5x plus 9x is 14x. Positive 3 minus 33 is negative 30 equals 180. Add 30 to both sides. 14x equals 210. Divide both sides by 14. X equals 210 divided by 14 is 15. Final answer.